couple of days ago that we want to be able to take a graph and then change that and to be able to calculate velocity from the graph to see how fast the object is moving, or the velocity of the object. So when we're graphing, we're always going to have the distance on the y-axis, as I have here, and the time is always going to be on the x-axis, okay? And when we had that straight line before, and we had something like this, how do we calculate that? Anybody remember how we did that? It was what over what? Let's say I had, let's see, 1, 2, 3, and let's say I had 2, 4, 6. And if I went here, how would I calculate my velocity? Here's my velocity here, distance over time. Okay, so how would I calculate that? 6 over what? Okay, 6 meters over 2 seconds. And that will give me what? 3 meters per second. Everybody understand how to get that? That's what we're talking about. All right, so let's look at a couple of things. Okay, this is a very simple one. And by the way, what does that straight line represent? An object that's what? Moving at a constant, what? Velocity, right? All right, let's take a look at this. Zero velocity, when we get a zero velocity, that means you're not what? Moving. It's not moving. So on a graph, what that will look like is a straight line. So let's say I started off going, let's go and put some more times here. So I started off going at a constant rate, and all of a sudden here, there's a flat line. Okay, what happened?
It stopped.
I stopped for a taco. Or something happened, right? Or I had a flat tire or something. Now, how come it doesn't just stop here? How come the line goes this way? Because time is still going. Time never stops. Right there, I just spoke, and you're already a second or two older than what you were 2 seconds ago.
I'm getting old.
Okay, all right. So that's zero velocity. So it's going to be represented by a flat line or no slope. Okay, now, positive velocity, remember we talked about what the word, the symbol positive means? It means what?
Forward.
Going forward. So you are going forward. Upward slope. So anytime we start moving, this line has to start moving up. It may move like that. It may move up this way. It may move this way. All that depends on my what? The steepness depends on my what?
Distance, like.
No. Yeah, my velocity. My velocity. But if I do move, it's going to go upward. Everybody understand that? Okay? All right. Okay. Negative velocity means that you're going what? Backwards. And that's important because a lot of times in math we think of negative as subtracting from something or taking away. And in some ways it is, but in more ways when we think about motion, it's moving backwards. Okay? So in that case we would see a downward slope. So it would go this way. So what did I just do in that 1 second? I put the car in reverse. Okay, everybody got that? Okay, I don't want anybody writing this down. I just want you to pay attention to me. You're writing, you can't listen at the same time, okay? All right. Now we get here, we got constant velocity. We just talked about that. And that just means, obviously, that's going to be just a straight line. Okay, that's constant velocity. Okay, and the speed never changes. It's constant. And then the average velocity is you're going to take this entire trip. So you're going to take from here, the total time, and you're going to take the total distance. See if I came all the way over here, it'd be 8. And then you will get your overall average velocity. Average velocity, okay? If we did that. All right? So would you calculate your average velocity the time that you stopped?
No.
Would that be part of your calculations?
Yes.
Yes, it would.
Well, like.
So if you were going to take a trip that took you 2 days and you spent a night at the hotel, that would be calculated into your travel time, even though you were sleeping that night. Okay? Is there any questions in that? All right. Okay, I'm going to go ahead and give you your